In this video, we are going to learn algebraic methods of solving a pair of linear equations. Actually, in the previous videos, we discussed how to solve a pair of linear equations graphically. But graphical method is not convenient actually, because if we get the point in decimal, for example 1.75, so it is not possible to plot exact position of 1.75, and there is, if we get a non-terminating, non-recurring decimal 1.333 and so on, so it is also too difficult to plot the point in the graph. And if we get the square root values, so where to plot the square root value in the graph? So in order to avoid this confusion and for clarity, so we have another method, algebraic method. And this algebraic method, we have two methods here. So in the algebraic methods, we have two methods. One is substitution method, which we are going to learn today. Substitution method. And there is another method, that elimination method. Okay, we will learn in exercise 3.3. Okay, so now we are going to learn substitution method. Let us see example 4. You will understand better. Example 4. Solve the pair of linear equations by substitution method. So given pair of linear equations, given pair of linear equations, see here, 7x minus 15y equals to 2, that is equation 1. X plus 2y equals to 3, let this equation 2. So from these two equations, okay, from equation 1 or equation 2, you separate any x value or y value. Okay, so from these two equations I take this equation 2. From equation 2, x plus 2y equals to 3, I will separate x plus 2y I don't want, I send to other side. Okay, then it becomes 3 minus 2y. So I am sending this 2y, entire 2y, so that's why it is plus 2y, then it turns into minus 2y. Now let me think, this is equation 3. This equation 3 has arrived from equation 2, so I should not substitute this in equation 2 again. So I have to substitute in the remaining equation 1. Substitute equation 3 in equation 1. So equation 1, 7x minus 15y equals to 2. So 7 into, instead of x, I will place 3 minus 2y. 3 minus 2 minus 15y equals to 2. So 7 3 is 21 minus 7 2 is 14y minus 15y equals to 2. So next, 21 minus 14 minus 15 minus 29y equals to 2. Okay, so plus 21. Transfer to other side, it becomes minus 21. So 2 minus minus 21. Minus 29y equals to minus 19. So minus minus will be cancelled. So y equals to 19 by 29. So this is the y value actually. Okay. Then let us find x value. So already here is x now. So you substitute this y value in equation 1 or equation 2, equation 3. You will get x value. See, I take equation 3. X equals to 3 minus 2y. So x equals to 3 minus 2 into y value 19 by 29. So 3 minus 2, 19, 38 by 29. So x equals to 29 threes. 29 threes. Okay, 3 minus 27 and 3, 2, 6, 8, 87. So 87 minus 38 by 29. So finally we get x equals to 87 minus 38 is 49 by 29. See how simple it is. So substitution method, we got x value and y value. it is very simple that two equations will be given, equation 1 and equation 2. From these two equations, you separate x value or y value. This is your wish, your convenience. There is no certain restriction. To separate any variable x or y and substitute in another equation, then we'll get certain x or y. Then substitute in any equation, we'll get the another value. Simple. Look at the example 5. To solve the following question, Aftab tells his daughter, 7 years ago I was 7 times as old as you. Tell them. Also 3 years from now, I shall be 3 times as old as you will be. So represent the situation algebraically and graphically by the method of substitution. Okay. So let us keep algebra graphical method aside. So find the solution by substitution method. And you know very clearly our lesson concept is pair of linear equations. So pair, there will be two equations. So two situations will be narrated in every question. So here also Aftab 7 years ago is narrating and Aftab after 3 years ago. Okay. So very simple concept. Example 5. Two characters are there. So let Aftab age present. Okay. So let present Aftab age equal to x years and his daughter age equals to y years. So the first situation is 7 years ago. When I tell that 7 years ago Aftab, it is equal to again both will go 7 years back, which means Aftab will go 7 years back and his daughter also will go 7 years back. But 7 years back, the situation was Aftab was 7 times of his daughter. Okay, 7. So simplify this one. X minus 7 equals to 7y minus 49. So x minus 7. So let everything comes in one side. 7y plus 49 equals to 0. X minus 7y, then minus 7 plus 49 plus 42 equals to 0. This is equation 1. And observe the second situation. 3 years from now. Okay. When I say 3 years from now, it is 3 years added to Aftab as well as 3 years added to Aftab's daughter. And after 3 years, what is the situation? Okay, Aftab will be 3 times of his daughter. 3 times. So simplify this situation. X plus 3 equals to 3y plus 9. X plus 3 minus 3y minus 9 equals to 0. X minus 3y minus 6 equals to 0. Equation 2. Okay. So 3 minus 6, 3 minus 9 equal to minus 6, no? Okay. From these two equations, you take from any equation and separate the x value. I take this one. Equation 2 I take because it is easy to separate the value x from equation 2. From equation 2, x minus 3y minus 6 equals to 0. I send this minus 3y minus 6 to other side. Then it becomes plus 3y plus 6. That is equation 3. I substitute this one. Okay. Substitute equation 3 in equation 2. Don't substitute equation 3 again in equation 2. Okay. Because this equation 3 has arrived from equation 2. Okay. Again don't substitute there only. To substitute in equation 1. Okay. Sorry. Equation 1 substitute. So then x minus 7y plus 42 equals to 0. This is equation 1. Instead of x, I write 3y plus 6. 3y plus 6 minus 7y plus 42 equals to 0. So 3y minus 7y minus 4y plus 6 plus 42 plus 48 equals to 0. Next, minus 4y equals to minus 48. So minus minus will be cancelled. 4 ones 4 12. So then y equals to 12. So which means y, we got his daughter is, present daughter is y. You substitute this in equation 3 again, you will get x equals to 3y plus 6, no? So then x equals to 3, y value 12 and plus 6. Okay, so then x equals to 3 12 36 plus 6. So x equals to 42. So therefore the present age of Octav is 42 years, and present age of his daughter is 12 years. Okay, third. So look at the example 6. Okay, in a shop the cost of 2 pencils and 3 erasers is 9 rupees, and the cost of 4 pencils and 6 erasers is 18 rupees. Find the cost of each pencil and each eraser. So by substitution method, let us find cost of, okay, the given pair of painted equations, and let the pencil, okay, let the, I think let the pencil equals to x and pen equals to y. Okay, so that's why 2x plus 3y equals to 9 and 4x plus 6y equals to 18. So by substitution method, so from any equation you take, okay, so they have taken from equation 1. Okay, and try to understand this. From equation, they have taken from equation 1, they have taken from equation you got this, so x equals to 9 minus, and I will explain how it is. 2x plus 3y equals to 9, no? So 2x equals to plus 3y, you send the other side, then it becomes 9 minus 3y. So x equals to 9 minus 3y. So what 2 is doing this side? Multiplication. Then it becomes division. So it divides. So x value got 9 minus 3y. So this is what. So substitute this equation in equation 2, because we got this equation from equation 1. To substitute this equation in equation 2, then tremendously you got LHS equal to RHS. What a tragedy! LHS equal to RHS you got. In that sense, what the equations they have given or what the equations are formed are same, which means they both are coincident lines. Okay, they both are coincident lines. If we get LHS equal to RHS, while substituting, they both are same equation. So they will have infinity of solutions. They will have infinity of solutions. Exactly, I cannot say according to this question the pencil cost is 2 rupees, the pen cost is 6 rupees. No. Okay, from this given information I came to conclusion that when these two equations are same, they have infinity of solutions. Okay, so specific cost is not found out. Okay, it is too difficult to find specific cost. These two equations are coincident lines, will have infinity of solutions. Look at the example 7. Look at the example 7. Two rails are represented by the equations x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Will the rails cross each other? So the given pair of linear equations, let this equation 1 and this is equation 2, and from equation 1, okay, so from equation 1 we got this x minus 2y minus 4 equals to 0. This is from equation 1, and x equals to plus 2y plus 4. You will get it. Let this equation 3. See here, this is equation 3. So when it is equation 3, substitute in equation 2. So when you substitute in equation 2, see LHS is not equal to 0. LHS, how this minus 4 equal to 0? Which means LHS is not equal to RHS. And neither you get X value nor you get Y value. Okay, no X value, no Y value you got. And LHS is not equal to RHS. Observe the previous question. In the previous question, you got LHS equal to RHS, which means they are coincident line. Here you got LHS is not equal to 0, is not equal to RHS, which means these lines are parallel. These lines are parallel. So no relevant equations are formed here. Okay, which means they are not crossing each other according to the question. What they asked you. So will the rails cross each other? No, rails are not at all crossing each other. So try to understand. Okay. If the question without getting x value and y value, LHS equal to RHS, they are coincident lines. Okay. If LHS equal to is not equals to RHS, they are parallel without getting x and y. Then when you will get x and y, when they give you intersecting lines, exactly. Try to analyze the concept very clear. When they give you intersecting lines only, you will get x and y. If they don't give you intersecting lines, definitely it will be in these two situations. Okay. Thank you so much.